Hey everybody, it's Mr. Carr again. Today we're going to be talking about 1.3. It's our last lesson for this unit 1. And we're going to use something what's called inductive reasoning to discover patterns and numbers. Okay? Understanding patterns and figuring them out, so essential in geometry. It's going to help you being able to work through these kinds of ideas. Is going to help you through a lot of other logic and reasoning type things throughout the rest of the semester here. All right. So in example 1, we're going to make a conjecture, which is basically just an educated guess, for the next term in the sequence. Then determine the next number in each sequence. Okay. So when you look at this, what we're trying to establish when we look at these numbers, is there a pattern for them? So the first thing we like to do with these types of number patterns is, let's just do a simple addition. So if I go 2 to 6, that is plus 4. I go 6 to 22, that is plus 16. Okay, 22 to 56 is, should have given myself a little bit more space here. There we go. Let's try that again. Okay, plus 4, plus 16. Okay, 22 to 56 is plus 34. And then 56 to 114 is going to be plus 58. So if I were to say, like, based on that pattern, what's the next number? I don't know, probably something bigger than 58, I'd say. So instead of me just trying to take a random guess, I'm going to take it to the next step. Let's look at 4 to 16. Let's see if there's any patterns for this number. So if I go from 4 to 16, that's going to be plus 12. 16 to 34 is plus 18. And then 34, sorry about that. We're going to pause that one. All right, now I'm back. Let's go and finish this one up. So 34 to 58, okay? So I'm going to figure out that one. If I need to, I can work it backwards and subtract. So that would be doing 58 minus 34. But bottom line is it takes me plus 24 there. Okay, so this was called like the first level. Didn't really have much of a pattern. Second level, I'm kind of starting to see a pattern here. It's a little bit easier to see. Okay, and that pattern is actually what's called the third level. Because if I go from 12 to 18, that is a plus 6. 18 to 24 is also plus 6. So that means if I were to look at from the third level, and like when I look at these, every level is describing the numbers above it. Okay, so the first initial sequence of numbers is kind of like my 0 level. But then when I go down, I didn't have a pattern. My second level down, then there's starting to, I can see a pattern easily. The true pattern is from the third level. So because the third level is describing the second level, I'm going to apply that plus 6 to the next spot here, which is going to be 30. Well, remember what the 30 represents. 30 is going to represent, how do I get from 58 to the next level on here? So I can take 58 plus 30 is going to give me 88. And again, the first level is describing the numbers above it. So the plus 88, I've got 114 plus 88 now. And that's going to, whoa, hello. So 114 plus 88, that's going to give me 202. That is how I get to that next number based on my sequences here. Okay. Let me do these 2 more examples, and then I'll talk about what's over here in the annotate section here. Okay, make a conjecture for the next number in this sequence, then determine the next number in each sequence. Okay, so 14 to 22, 22 to 32, and then 32 to 44. 14 to 22, that is going to give me plus 8 to get there. Then I'm going to go plus 10. And 32 to 44 is plus 12. Well, you could probably figure out what the next number is, but bottom line is if I look at the first level, I don't have a common number. But if I look at the second level, these are all plus 2s. So that means my next number here should be a plus 2, making this first level here a plus 14. And 14 is describing how do I get from 44 to the next number. So I can do 44 plus 14 now is going to give me 58. And that's how I get to that. So this is called a second level common difference. Okay? That's how I describe this pattern as a second level common difference. At that second level, they're all the same. Okay? If I went up here, this is a third level common difference. Okay? Now, what does it mean to have these certain levels of difference? We can actually identify what kind of function that is based on that. And so what I mean is this. If I look at these right here, we saw the first level, we saw the second level there. Sorry, we saw the second, we saw the third level. That third level difference makes this first example a cubic function. Okay? And what that means to be a cubic function is it would y equals x to the third power is roughly what it looks like. Okay? You can actually, there is a way to model what's going on here using a formula, and it's going to be something to the third power like that. Okay? It gets more complicated. It could be like 2x cubed plus 3x squared plus 4x, blah, blah, blah. That's just one thing. When I have a second level, that is a quadratic. So this is going to be of the format y equals x squared. And again, you could be y equals x squared plus 2x plus 4. Okay? That's what the second level difference tells us. If I have a first level common difference, it's a linear function. So for example, here's one way I could show that. So let's say 0, 1, 2, 3. I can go 4, 6, 8, 10. This is just a different way for me to organize it. I'm just putting it as an XY chart like that. But if I look at these numbers here, this is going plus 2, plus 2, plus 2. That's my first level common difference. So that would make this example a linear function. Okay? So that's the idea with our number patterns here. And then thinking along the lines of patterns, we want to make like what helps us, like what we are doing with inductive reasoning is we are trying to analyze, here's a pattern of numbers, what do we think comes next? Because in every case, we feel pretty confident that that number was there and that number was there. But here's the thing, where's the guarantee that that's happening? We don't know for sure if that's the number. We're just kind of making a pretty good educated guess. That's what inductive reasoning is. You're taking the evidence in front of you and making an educated guess of what's going to come next. So sometimes there might be what's called a counterexample. So in terms of logic, a counterexample is just one example that proves something false. Okay? So counterexample is just all it is one example that proves a statement false. Not quite enough room there. Okay, so that means like if I look at this statement here, if you live in Chicago, then you are a Cubs fan. Hopefully that's true, but if it's not, here's a counterexample. What if you live in Chicago, but you're a White Sox fan? That's a counterexample. My writing was pretty terrible with that. Let me fix that a little bit. Make it look a little bit nicer. Okay, but White Sox fan. Okay. Or no fan. Okay, who says you have to like baseball. Bottom line is all you need is one counterexample. Then I can say that this statement is false. Okay? So that's all we need. So that's our idea for logic and reasoning. That's our patterns. Next time in class, you know what? Instead, because here's what we're going to do. We're going to do these together just to make sure that we're clear instead of having you try the analysis in class. Because in the next time in class, we're going to try doing our next quiz. Okay? So it says here, make a conjecture for the next term in the sequence, determine the next number in each sequence. Finally, describe the functions, linear, quadratic, or cubic. So we need to do three things. We need to make a conjecture, which is basically trying to say what the pattern is. Okay, and then we're going to figure out the next number. Then we're going to name that function. So we got 5 to 15, that's plus 10. 15 to plus, 37 is plus 12. No, it's not. Hello. Plus 22. 37 to 77 is plus 40. You know what? I'm going to zoom in. Let's redo that. Okay. Plus 10, plus 22, plus 40, plus 41. No, wow. It's been a long day for me. Plus 80, where am I at? Plus 84. Okay. Let's look at something different there. All right. First level, not the same. So I'm going to take it to the second level. Let's check these numbers. Going plus 12, plus 18, plus 24. Geez. Yeah, I'm having troubles today. Okay. This 77 was plus, that was plus 64, not 84. Now that makes that work better. We all make mistakes. It's all right. We'll learn from them. Okay, so my first level, not the same. Second level, not the same. But third level, plus 6, plus 6. Okay, so here's what I'm going to write for my conjecture. I have a third level common difference of plus 6. So now, to figure out the next number, I'm going to go ahead and apply that to the next step. So that's plus 6, which means this is a 30. That 30 is describing how do I get from 64 to the next number. 64 is telling me, 30 is telling me how do I get from 64 to the next number. So that's going to be a 94. And then 94 is describing how do I get from 141 to that next number. It's always a level above. So I'm going to do 141 plus 94 is going to give me 235. So that's my next number in the sequence. Okay, and the name of the function, because we have a third level common difference, that is a cubic function. All right, determine whether this statement is true or false. If false, provide a counterexample. If the distance from point A to point B is the same as the distance from point B to point C, then B is a midpoint. So this is one of the things we got to make sure we understand what a midpoint does. If the midpoint is exactly in the middle of A and C, then here's what we can state. We can state that AB is congruent to BC. So this is true. There's no way for me to make a midpoint where those two segments are different lengths. So it has to be in the middle. Another way to show that congruency, we'll put a little tick mark on each. Okay, when I put a single tick mark on there, that means it's congruent. If I did double tick marks for both, then I'm saying those are congruent. But if I only did, let's say I did one tick mark here and 2 on the other one, then those two are not congruent. That's what those mean. But for us, we're going to say that's 2 and 2 is good. All right. Determine whether the following statement is true or false. If the food you eat is sweet, then you are eating junk food. So we want to come up with a counterexample. Let's try to say this. Okay. If I eat something sweet, I can eat. So I'm trying to figure out something that's true for the first half, eating something sweet, but false for the second half. That's my counterexample. So is there junk food or is there something that I can eat that's sweet that's not junk food? Fruit. I'd say fruit's pretty sweet. Okay. So you can see that we give specific answers an apple, but that's the idea. All right. So like I said, next class, we will go over some of these together, some of the homework more on that. If you have any other questions, please feel free to reach out through email or come to my office hours. Otherwise, I will see you tomorrow in class. All right. Take care.